Hello everyone, this video is about proving the Pythagorean Theorem. I'm sure we all know what the Pythagorean Theorem is. It states that a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. But I'm sure you have wondered, how can we prove that this is actually true? So I'm going to show you my personal favorite proofs. And trust me, it's very, very cool and it's pretty simple to understand. So let's get started. Now, let's say I have a right triangle that has legs of A and B and a hypotenuse of C. Now, I'm going to take this right triangle and I'm going to arrange it in such a way that it forms a sort of square, okay? Now, this total square, is going to have side lengths of A and B alternating. So we've had four exact copies of the same triangle we took before, and we've arranged them in a sort of square shape. Now, since this is a square, the internal square is going to have the side lengths of C, because those are the hypotenuse of our four copies. Now, let's take one of those. For example, let's take one of the triangles out of there. And now I ask you, what is the area of this triangle? We know that the area of a triangle is 1/2 base times height, or 1/2 BH. So 1/2 of the base times height. So the base is going to be A and the height is B. So when we plug it into our formula, we get that the area is 1/2 A times B, or 1/2 AB. And we can rewrite this as the area equals AB over 2. And that's going to be the area for this one triangle here. Now, we have four of the exact same copies. So we're going to find the area of all four of these triangles. We just multiply whatever the area was for one of those triangles, since it's a series of copies. So we get that the area of all four triangles is equal to 4 times AB over 2. And this can be rewritten as area equals 4AB over 2. And the 4 and 2, they cancel out, leaving just 2AB behind. So again, this is the area for the triangles. Now let's take a look at the square that is inscribed in the middle. We know that the area of a square is just s squared, or side squared. So the side lengths are c, which means that the area is c squared. And that's the area of our square. Now we know that the area of these two components, well, we know that the area of the four triangles added with the area of the square is going to give us the total area of our bigger square. Now, if I were to ask the total area of this whole square, we can express that as a plus b whole square, because the sides are a plus b, and we do a plus b times a plus b, which is a plus b whole square. And when we expand this, we get that the total area is equal to a squared plus 2ab plus b squared. Now we can rewrite this, since we know that the area of the smaller figures that add up to a larger figure are the same thing as the area of the larger figure. We can say that the area of this entire square can be represented as the area of all four triangles plus the area of that smaller square inside. So we can express this as a squared plus 2ab plus b squared is equal to 2ab plus c squared. Remember, 2ab is the area we found for all four triangles, and the area of the square is c squared. Now, if I subtract 2ab from both sides, that cancels them out. And finally, we are left with a squared plus b squared equals c squared. And if you notice, that is exactly the Pythagorean theorem. So this was one of my favorite proofs, and we learned about it in geometry class. And I just felt it was nice to share this because it's always nice to understand why the formulas work, or, well, proving the formulas, because math is a lot more beautiful when you understand why it works. And that's going to be it for this video. There's many other proofs for the Pythagorean theorem, but this is one of my favorite ones.